For those of you who are joining for the first time, you might be a bit surprised by that. No worries, we actually recorded the first two. So if you take a look at the EdgeX Foundry website, go into the developer pages and look at the wiki, you will find on there a section called EdgeX Text Talks, and you'll find the first two recorded there. So please avail yourself of that. If you are looking to get started in developing with EdgeX, you'll see a recording on how to do that. If you're looking to try just get the Docker containers up and running and not necessarily develop, but want to get everything up and running from a Docker perspective, there's a talk on that too. Today's talk, as you can see by my title slide here, is all about looking at the core data. We typically, from a Dell perspective, look at this as kind of the first and foremost of the microservices that are out there. It was the first one that I built almost 2 years ago to the day now. So it is where we usually start off training people who are getting into development once they've got their environment set up. So hopefully today's talk will, for those of you who are looking to develop, start to get you into the code a little bit deeper than maybe you have already. For those who have not, or I should say for those who have already started development, some of the topics today may be a bit rudimentary and introductory, and you may say, okay, let me zone out and do some email for those pieces, but there might be a couple of areas where we'll shine some new light on it for you. And then of course, at the end of the day, we are going to do our question and answer period. So give you a chance to ask anything about any aspect of EdgeX, to include things outside of even core data. So our agenda is this. We're going to take a look again, the general purpose and the background of core data. We'll look at its makeup. What are the technologies that are used in core data today? Not to say that those couldn't change as you, the open source community, takes a look at it and starts to work with it, but how it's built today. We're going to look at, importantly, the data model or the object model around core data. What are these things called? Event and readings, and what is a value descriptor? Three key ingredients that make up a lot of EdgeX, not just core data, but they stem out of core data. We'll look at the REST API around core data. So if you want to invoke something in core data, what does that look like? How does that operate? And in particular, we'll kind of give you the categories of the APIs out there, because it's a pretty thick API set. And we'll look at some important configuration of this microservice. What are the things that you can change? What are the things that you need to look at if you're going to start to deal with a different database, for example, or if you want to stream differently? We'll take a look at that as well. And as I mentioned, the last 30 minutes or so will provide for your questions, try and get you some answers about all things EdgeX, not just core data. Again, folks, my name is Jim White. I work in Dell. I am the father or grandfather, as one of my developers called me the other day, of what was Fuse and now what is EdgeX. That makes me feel old. So hopefully here I'm going to start to transition that title to one of you in the not too distant future. If you have questions, if you have comments, concerns about EdgeX, you can see my email address is on the board there. So please feel free to avail yourself of that. I welcome questions. We are getting quite a bit of community participation right now, so it may sometimes take me a little bit of time to get back to you, but I absolutely guarantee a response at some point in time as soon as I can get to it. Okay, let's see. Let's talk about big picture. What we're going to talk about again today is core data. This is the now infamous diagram of EdgeX. All of the microservices being depicted in this particular box, or at least those that are part of EdgeX today. Each one, again, is a self-contained microservice, and each one communicates today largely via REST. There's a couple places where they do communicate via message technology like 0MQ or MQTT. We are going to focus in on the one here highlighted in red, core data today. That's our focus, kind of the first of the key services, and obviously the one that's key in the core services area. So what is core data's role inside of EdgeX? For those who are already participating, yep, I know this is pretty rudimentary, but for those who are just getting started, what core data provides is a centralized persistence facility for data as it's being collected up by devices and sensors. So let's say you got a thermostat. It's collecting the temperature and humidity. It then wants to send that to something in EdgeX. What is that something? It is core data. That's where the data, the sensed data, is stored in a persistent facility. In particular, we'll see that's MongoDB today. That is also where any other part of EdgeX, or for that matter, any other system, can come and get those historical readings. We provide an API for you to essentially say, what was the temperature in room X sensed by that thermostat over a given time? Device services and devices are what are actually collecting that data, and they're going to pass that data in a RESTful manner, at least today. This provides not only for looking back historically at the data, but it also provides for what we call store and forward technology. In other words, if you're operating in some sort of disconnected fashion, you want to be able to store that data temporarily and then push it off when you're reconnected to a system. Think of a boxcar that maybe has an EdgeX system on it that's only intermittently connected to the cloud. This allows for that capability. It also allows us to, as I mentioned, provide for actuation back down. If the temperature is 72 degrees, then turn on the heat. If it's 80 degrees, turn on the air conditioning. The only way we're able to do that is to somehow have a mechanism that knows what that temperature is and can express that and provide it to those intelligence systems, those analytic systems at the edge to act on. So data is stored in Core Data's database until when? Well, until it's either moved off and what we say exported to the north side, in other words, exported out to things like your enterprise and cloud systems, or when it is scrubbed, or what we call cleaned up. If we kept all the data all the time for all sensors, we're going to eventually run out of space on whatever platform EdgeX is running. So we have to eventually clean that data out. That's configurable, but today, by the way we do things in a default fashion, I think it's every 3 days, or I should say data that's older than 3 days gets scrubbed off the system. Again, that can be adjusted. You can make that scrubbing happen sooner or later, but the idea is that eventually you want to clean that data off. And you could also do it so that once it's actually physically moved northward, you may not need it on that system anymore, and you can make that kind of the triggering mechanism to scrub the data. We provide an API, again, a REST API around the services so that it can be accessed historically by other pieces of either EdgeX or by other systems. Now, this is one that we will tell you should be used sparingly. Core data is at the heart of bringing data in from sensors and devices. We don't want to interrupt that flow by somebody's huge request for all data in the database. If core data is shelling out data to all these other services or to all sorts of off-box systems, you can imagine that core data is then going to be so busy that it may not be able to deal with the requests coming up from devices and device services about new data coming in. So even though that API is there, what we would encourage you to do is instead become a client of the export services to get the data. That's done in an asynchronous fashion and doesn't interrupt core data to provide you that data. So as we start to look at the services, the microservices within EdgeX, and one of these days when we take a deeper dive into export services, that would be where I would encourage most of our applications, most of our systems that request the data coming out of EdgeX to get their data and not go directly to core data. But it's there for the absolute needs and for those eventualities when there's just no other good way to get it. Core data has also been set up to provide for a certain degree of security. Now, I use the word here and emphasize the word could. It is not there yet today. Security, system manageability, things of that nature are still to be built into EdgeX, and why largely the community is focused on that for some of our upcoming releases. But in theory, and in some of the proof of concepts we did at Dell, the idea is we could easily build around core data a mechanism such that, for example, data is maybe encrypted when it's at rest, or even encrypted before it's exported off the box. So there is a certain amount of security that is availed through having this one service kind of responsible for data as it flows through the system. Okay, so what's the makeup? How does core data work? It is, as with most of the code that we wrote in Dell, it is Java-based. We do have some services that are not in Java, and there are replacement services that I'll talk about coming up that are not in Java. But today, core data is made from Java. We used heavily or relied heavily on the Spring framework, and inclusive of that, Spring Boot. And we use Spring MongoDB to access the Mongo database that is underlying EdgeX today. Again, we're using REST communications in and out of core data, and so Spring MVC and its REST communication ability is what's largely providing for that apparatus as well. For those of you who are familiar with Spring, you'll see here in a bit when I bring up some of the controllers that are in place, just how much of Spring we used. It's actually, when you understand Spring, a lot of core data, in fact, a lot of the Edge microservices are pretty simple because Spring does provide a lot. Of course, with that providing a lot, it's also the reason that we do have some big footprints and some performance issues we're going to have to wrestle with. And we'll talk about that as we proceed with some of these tech talks going forward and give you some of our plans about how we're going to deal with that. There is a message pipe that does connect core data to the export services that I mentioned before. And in particular, by default, we use 0MQ to get the data pushed up into the northbound application sets, which include that export services and things like rules engine. When we initially built core data, we actually used a broker on the device, on the platform, and had core data use MQTT to export the data out. That scaffolding is still there. You can make a switch very quickly by a configuration change to go between 0MQ and MQTT. So the question is, well, why did we do that? Well, MQTT with its broker got to be really heavy, and in a lot of smaller environments or platforms where we want to have EdgeX run, we felt that 0MQ was going to provide a much lighter footprint and a much better option there. But the proof made by having these two communication protocols essentially in place between core data and those northbound services, it started to give us a pretty good indication that really EdgeX does avail itself to just about any kind of protocol between microservices in the future. So 0MQ by default today, but MQTT is option, and there's no reason why you couldn't put something else between the two, something like, say, WebSockets, for example. Now, as I mentioned, there is an alternate implementation that we've done in several different cases for core data. What's out there in the open source community today, again, is Java Spring based, but we actually, and working with Mongo, but we actually did an experiment for one of our clients and actually redid core data using JDBC and SQLite in place of Mongo. We did that to kind of prove a point. This particular client created or had a database in its inventory, and so they wanted to see it working with that. But it also gave us pretty good proof positive that each microservice really is independent from the others. We were able to complete that work in about a week without any other impact, no API change, no other work necessary to get that to effectively take its place in EdgeX. So that tells us that going forward, there could be lots of implementations of all of these services to include core data to deal with all sorts of different apparatuses and databases and means of communicating. As long as it adheres to the APIs and as long as it does its job with regard to its expectations in the EdgeX microservice community, then we feel it's fair game to use whatever technology you feel is appropriate for your use case. To that extent too, Dell has also created some partial core data replacements using Go at the core data level. Core data, metadata have all been started in Go already. We're not there yet. We still have some work to do, and we're planning to try and get done either this summer or in fall. But again, the idea here being that you can replace any one of these services as long as you understand the API set and its role. We feel that these services are easily replaced. It provides a very flexible and powerful environment that allows for value add going forward. So what we talk about today with regard to things like APIs and data models, recognize that I'm not going to take you too deep into the actual code base. If those of you who want to get into it and understand things like Java and Spring want even more data, information and data about it, we can get into some of that. But you'll recognize I'm really starting to focus in on things like APIs and data model because that's what's the heart of any one of these microservices. Okay, so let's dig into some of that a little bit deeper. With regard to how core data works from a sequencing standpoint, to kind of get a picture for the workflow that core data participates in, it has a few different workflows from the perspective of, addressing things like different queries and such from, say, some sort of client, which I mentioned is something we want to kind of de-emphasize, but as its main job, and that is getting data from things like devices and device services, getting that stored and persisted and pushing that up to northbound capabilities and applications. How does that work? This diagram, the sequence diagram, hopefully addresses that for you. Oh, and by the way, everything that I'm showing you in these decks, this is not information that has been suddenly created for these talks. All this information is actually available on the wiki site. In some cases, you might have to dig around a little bit for it, but it's all out there. So we're just kind of repositioning and re-putting this together for these talks. But things like this diagram are available on our wiki site. So when we look at this workflow, let's take a look at how this core data service behaves with regard to the capture of data from a sensor and making that available to northbound systems. It starts with a device. a device is going to somehow produce some sort of sensed value, and it will push that. Typically, it could be done asynchronously, and it could be done by some sort of poll that is a bit dependent on the device and device service. But let's say, for example's sake, that it's going to push that data into a device service that's responsible for that particular device. That device service is then what's translating the information in the format and protocol of choice for that device or sensor into the EdgeX format and communicates that data into core data. So it's going to have to do some sort of normalization into what we call events and readings, and we'll talk about what those look like and how those behave here coming up in just a bit. And once it's done that normalization effort, it's at that point that the device service is then going to communicate via REST today. It'll make a REST post call into core data. And when it sends that data in, and again, what we call event reading format, it will associate the device ID to that particular piece of data. So we can tag each particular element that comes into core data to a particular device. And in fact, we can actually timestamp that as well. More on that coming up in a bit. Once core data receives that post request for that data, its next job is to, first of all, potentially check that that data is actually attributed to a device it knows something about. Now, we'll talk about some options here, and this is one of those things that if you trust the device services and you believe the device ID is accurate and validated, you do not have to actually do this step. But for safety's sake, we provide a mechanism for core data to talk to another of the core services called Metadata to check that we actually know about that device, and then tell the core data service that, yep, we're good to go there, or send back an appropriate error response mechanism that says, hey, that device is just not known, so reject that data essentially and allow the device service to deal with that consequence. Once we've got an indication that the data coming in is valid with regard to some sort of device we know about, it then will insert that data, the event and reading, into our database, which again for us today is Mongo, at least by default, but as I indicated, it could be your database choice. We send back to core data the identifier, and in fact, core data will rely that identifier about that event reading onto the caller, in this case, the device service. And at that point, core data will also queue that data up into that message bus. Again, for us, that's 0NQ by default, so that it can be pushed off to, again, those northbound export services where it can be sent off to your enterprise or to your cloud, whatever you have above EdgeX. And again, finally, we send back that information to device service that, hey, your event has been essentially registered, we've got it, and it has been moved on to the rest of the system. So that's the big picture. That's where core data sits in the flow of data from what we call the south side, or device and sensors, all the way up to what is essentially the northbound edge of EdgeX. So what's our model look like? What is the communication, that normalization that I talked about, that device services do to transmit the data into core data? We keep the simple model here, folks. We chose a very flat, very easy to understand model, and we did that for a reason. Yes, we know there are lots of different types of standardization going around this with regard to other IoT consortia. We know that one might someday evolve to be the selection for the model in all IoT systems. What we found, though, was in trying to deal with those today, they're not quite there in terms of standardization. Not everybody's adopted them. Your model might be your favorite model, but not the next guy's favorite model. So essentially what we have in EdgeX is a double transformation engine. One at the bottom to take something like Modbus data or BACnet data and get it into our core data model. And then at the edge, at the northbound edge, transmit that in whatever your model of choice or favorite flavor is, going to the north side. So to keep things very simple and easy to use in between, our core data model is what we kind of selected to keep things going. How does the core data model work? We have events and we have readings. Those are the two key ingredients. An event is nothing more really than a wrapper. It's a wrapper that associates a bunch of readings together. A reading would be something like, hey, the temperature in the room right now is 72 degrees, or the humidity is 88%. Now we do that in a very simple fashion. A reading essentially is nothing more than a key value pair. The key is a name to something we call a value descriptor. That would be something like temperature or humidity. And the value is just that, the value that was sensed. We don't even type it here. In other words, what is the value and what type it is really isn't a concern in the reading. It's a key value pair. Now, there are a couple other pieces of information that go with this event and reading. We have, again, the device ID that is associated to the collection of data, to the event and its readings. And we have things like the push time, when that data was actually transmitted to the northbound side, so we can register the fact that it has been taken care of and pushed all the way to your enterprise or cloud system. And at the base object level, which these extend, things like when the data was actually created, when it was modified, what its origin is. Now, origin and created could be different. Your sensor may have some intelligence and be able to timestamp the data, in which case it has an origin. But then once it actually gets created in the core data, we put a created timestamp on that. In particular, that might be useful where you have a dumb device and it can't timestamp the data. So event and reading are pretty simple. An event is comprised of one or more readings. The readings are a key value pair that are the sensed data. The real important information with regard to the core data model is really down here at the value descriptor level. The value descriptor has a name that has to be unique across all of EdgeX, and that is what provides the characteristics. It provides the context. It provides the unit of measure for that reading value. So every reading has a key value pair, and as I mentioned, the key is a value descriptor. Let's say your value descriptor or your key in a reading is temperature. The value descriptor called temperature would give you information such as, well, what is the minimum value? Presumably in something like temperature, that might be a minus 25 Celsius, for example. What's the maximum temperature? Maybe that's 125. What's its type? Is it an integer? Is it a float? What is it? What's the unit of measure that we use for that reading? For temperature, that might be Celsius or Fahrenheit. A default value. What's the formatting mechanism for how we display that reading value? And any labels that we want to use or apply to that value for searching and querying capability. So as you can see, that value descriptor is a very powerful mechanism to provide lots of context around a reading, but that value descriptor is obviously going to apply to lots of readings. So we don't store the value descriptor information with every reading. We only tag a reading with that value descriptor name so that the readings themselves are very, very small. So again, gang, in kind of summary of the model, we've got events and readings. Events are nothing more than collections of readings that are associated to a particular device. A reading represents a sense value from a device or a sensor, and it's really nothing more than a simple key value pair. It's the value descriptor key that's the important part. Events would need to have at least one reading to make sense. It would make no sense to have an event without at least one reading. And readings have to be owned by at least one event. So kind of in a diagram, this is what we're looking at here. An event associates readings to a device. The reading itself just provides a key, which is your value descriptor, and the value that was sensed. On the value descriptor side, again, it provides a context, the unit measure to a reading, has to have a unique name. It specifies all the details about a particular value, min, max, default values. Essentially, a value descriptor is the tagging mechanism we use to provide amplifying information about those sense values. By the way, too, the value descriptor, while it's being kind of managed from a core data perspective, the metadata system actually uses value descriptors as well to describe when you're describing a device, what type of data we should expect from a device. And it is used also to describe the parameters we need to send to actuate on a device. So value descriptors are not only used to describe the data coming up from a sensor, but they'll also be used as we start to explore metadata in future tech talks, how we describe the devices and what they represent and what information they pass, as well as how to communicate with them. Okay, so let's get into a little bit of details. I told you that I'm not going to show you lots of Java code because really it may not be Java code that runs your core data system in the future. But let's at least get into a little bit of details about how one of these processors, if you will, one of the controllers inside of core data works. In particular, we're going to look at the event controller. So forgive me as I pop out of here and into another screen real quickly here. Okay, so this is core data, and this is directly from GitHub, and I'll zoom in on that a little bit more for the visually strained like myself. This is a Java class, and what a controller represents is that endpoint that people communicate with, in particular maybe the device or device service communicates with, to either pass in events and readings or to get information about an event or reading back out. In particular, the event core controller is obviously what deals with events with regard to core data. So for those who are Java Spring aware, you'll recognize lots of annotations out there about defining it as a controller and how we map the REST API to this particular endpoint. You'll see lots of dependency injection going on there, in particular things like the Mongo database repositories. So this is how we actually communicate with the database underneath via MongoDB repos. You'll see other information, including things like values, which are attributes or application properties about how some of the configuration in EdgeX works, and we'll talk about that coming up in just a bit, how those are dependency injected and how those are checked at different discrete points in the code as well. What you'll then see is a lot of methods for how to either get, in this case, events out of core data, or in the case of being able to create new events with their associated readings, how to post those in. So as you can see, gang, this is where rubber meets road in terms of the REST API offering with regard to any particular service within EdgeX, and in particular, how core data deals with event information in the EdgeX world. So here we see a pretty simple example inside of the core data's controller for events. Here's how you request, or this is the method, if you will, that would be hit if you request all events with a particular ID. So if you have the event ID that represents that event, this is where your request would land, and this is how that information is brought back up by core data and gotten out to you. In fact, all it does is make a simple request of the repository and send that data back out in JSON form. Again, as I mentioned, if we dig a little bit deeper into this particular service, we would see, and I have to go down a little bit deep here, but we would see, there we go. Here's how we add a new event and its associated readings into core data. It's just a simple method done via post where the body, which would be in JSON format, gets translated by Spring into an event object, and then we again use the repository to persist that data if you do request it to be persisted. We'll see there's an option here, a little secret and not known to everybody who hasn't dug deep into EdgeX yet. You don't actually have to persist the data. You can stream it through core data. We'll talk about that. But if you do choose to persist it, here's how it does its work. It persists the event, persists all the associated readings, and then again responds back with a string, which is the identifier for that particular event. So pretty simple code structure when you look at a lot of the elements within inside of core data, or for that matter, a lot of the microservices that are built into EdgeX. Most of them follow what we call an MVC pattern, if you're familiar with that design pattern. Okay, let's go back to the topics at hand here. So that's core data's event controller. Pretty representative of all the controllers inside of core data, or for that matter, any one of the EdgeX controllers out there. Let's talk now more about the APIs. You saw a little bit of the APIs and how it's represented inside of that Java code. What are all the APIs offered? There's a deep and rich API set here. So I'm going to kind of categorize them a little bit, and then I'm going to show you the Ramo document, which will give you a complete detailed list of those. So we have APIs around events, as you would imagine. And those APIs allow us to do things like post. You can delete an event and its associated readings. This is typically not going to be done by code you would write. This is typically going to be done by things like that scrubber that I talked about. And we've got gets galore, all sorts of get APIs to get events by their ID, as you saw. You can get an event by its associated device, by a timestamp range, by the associated readings, a value descriptor. You will see that with each of the microservices around EdgeX, there is, I think, a great availability to get information in and out of these particular services with a lot of APIs. You're probably only going to need a couple of them when you actually start to write some code. And we also provide some good, what I would call just kind of simple debugging capability. You'll notice with each one of the services out there in EdgeX, we built in this little check, for example, to get the particular object of importance in that service out with a count. So you can get all events by account. You can ask, how many events does core data know about right now? So that's a great little mechanism to get back a quick answer and just to see or ping that the service is up and running. We have APIs for readings as well. So again, remember, event has many readings. You could do a post, a put, or delete, but these are usually APIs, again, used only internally. We don't block them. That's something we might want to consider as we look going forward. What parts of the API should we really not provide access to? Typically, these APIs are going to be called by other elements within inside of core data, but there are mechanisms you can post a reading independent. Obviously, if you do that, you need to know how to associate it to a particular event ID, things of that nature. But they are available, just not often called by code that you would write. There are gets again galore. You can get readings by ID, by associated event, by unit of measure label, you name it. If there's a piece of information we know about in EdgeX, there's typically an API around getting it out by that same information. And again, we can get readings by their count. So give me all of the readings that are known by quarter today in a quick fashion, so I can just see if things are up and running quickly. Or maybe I can want to check that to see if the database is just getting too plugged and too full, and maybe I need to exercise that scrubber a little bit more often. Value descriptor APIs, yep, we have post, put, deletes, as you would expect for value descriptors, and again, gets galore. One other API we provide around core data, and with every microservice, again, we have a ping check in place. So there's a ping API. That particular service does nothing other than respond back with Pong. That's kind of our mechanism used not only by developers, but it's also used by our configuration registry service to continually check that, in this case, core data is up and running as expected. So as I mentioned, there is a Ramo document out there. You can find this inside of the EdgeX wiki repository. I'm going to take you to that Ramo document, and we actually use a tool called Ramo to HTML inside of Dell to represent that Ramo document in a little bit more user-friendly fashion. I would encourage you to do the same thing. Download the Ramo and then convert it into an HTML document that's a little more friendly to use. But that's where you'll see all of the APIs that I just categorized for you are represented. We provide the full API there. We provide some examples. So if you wanted to know more about, for example, that API for getting events out by, say, the creation time, you check inside the Ramo and you'll see how to actually make that call. So here would be the API into core data to do that. Give me all events between, in this case, a particular start and end time. We even provide an example and provide some details about some of the parameters used, if there are parameters for that particular request. So you'll get a request indication what the parameters are, and you'll even get an example of what the responses are going to be like. What are the particular status codes and error codes you'd get back, and what will the actual response in terms of JSON start to look like? Not only in terms of schema, but an example set there so you can have an appreciation of what type of thing you're going to get back, so you know how to code your end of that. So again, the APIs out there, all defined by Ramo. We've had people suggest, geez, it'd be really nice if we had the documents also in something like Swagger. Folks, that's what the open source community is all about. If you think the API set should be in a different format or be done by a different tool, send us suggestions, or better yet, help us out. Create that facility. There's no reason why we can't support multiples in this kind of environment. Okie dokie, let's see where we at. Back one here. Let me kind of wrap up our discussion with core data here about giving you some piece of information about if you're going to bring up core data. There are some configuration elements out there that have default settings, but you may want to also adjust or maybe configure them slightly different for your particular needs and use cases. For example, some of the important and unique core data configurations are that we have out there available, as I mentioned, an ability to actually turn that metadata check on and off for that device ID. So if you trust the device service to know its device IDs and know that they're going to exist, you can actually skip checking with metadata to ensure the device ID is correct or not. That actually reduces the amount of traffic that has to be occurring between microservices and obviously improves performance. There's an option in the configuration to turn off the data going up to the northbound services via that either MQTT or 0MQ message bus. There is an option to actually turn off the persistence of the data. If you so choose, you can say, do not store this information in Mongo. Instead, just allow the information to travel northbound through those message buses I mentioned. So essentially, you're streaming the data out of your devices and device sensors through core data all the way up to the northbound service. Now that has implications. For example, good luck in getting any historical information from your local edge system, but it does allow for that streaming idea. where you want to stream to, whether it be MQTT or 0MQ. Again, configuration options for that. Configuration options for where your database is and how you get access to it. Again, by default, we use Mongo, but there's no reason you couldn't configure for other options. And which particular message pipe you're using with regard to 0MQ or MQTT, and how you get access to that pipe, all configured by these unique core data configuration options that are specified in the application.properties file within inside of core data. There are also some standard configuration options out there too. What port core data comes up on. As with every EdgeX service, you have to define what port it's going to exist on. The location of other microservices, the log levels that are there, what read limits are in place for any particular microservice. Those are standard configuration options you'll see in every EdgeX microservice, and obviously they also apply to core data. More information, again, is available if you take a look in GitHub at the application properties, or if you look at the documentation out there for core data, you'll see these properties are represented. And I think, let me see here. Yep, that pretty much wraps up our discussion about core data. See, not too bad, 36 minutes to get through all that, so we'll have plenty of time here for your questions. Again, upcoming Tech Talks, send us a note. Let us know if there is something you'd like to have discussed. Also, note that next week's Tech Talk is going to be canceled due to the fact that we've got the upcoming tech meeting in London next week. Hope you all can join us, if not in person, at least online. So we'll resume our Tech Talks on July 27th. And I believe, and hopefully Brett will correct me if I'm way off base, I believe the next meeting in 2 weeks will also be in the evening, 6 p.m., because I think next week would have been 9 a.m. So in 2 weeks, we'll be talking at 6 p.m. Eastern Time again as well. Upcoming talks that we've got planned, we're going to talk more about metadata, command, things like console and config registry, and talk more about the SDK, but we are certainly open to suggestions. Send in your requests. With that, I think we're ready to open up for questions, and I'm looking at the chat area. I don't see any questions coming in. Brett, I don't know if you want to open up the lines for questions, or if we have maybe messages that have been sent to you directly. We'll open up for anybody's questions at this point.
Yeah, for everyone on the line, the lines are auto-muted when you join. If you are having issues moving off mute, just shoot me a quick email. I actually temporarily, let me move the folks who are dialing only off mute. That's usually extra tough. So the three folks that we have dialed in directly, do any of you have any questions to raise?
A quiet group in the evening time, Brett. Note to us, morning participants are much more active.
Yeah, go ahead.
Hi, this is Leon. Jim, I have a question since you mentioned the no persistent option, the streaming. There was a question that came up in one of the recent meetings regarding ability to sort of pass through the data from device all the way up to basically to the edges. And I know there were questions on top of that question that if that's the idea of what's the value that EdgeX is adding. But for the sake of discussion, I just want to make sure now that I better understand the API. So that was this no persist option that you were referring to, right? We can basically get the data from the device service directly sent up, and if the type above core data is not, let's say it's not a messaging type but some other format, it literally can go directly out to the node bound.
Yeah, great to have you online, Riaz.
Or was there more to it?
Yeah.
Was there more to it? Yeah.
Let me try to, and I've got a chat message that asked to please repeat the question because I think it was sometimes tough to hear that. So first of all, let me repeat, Riaz. So question is, if we are looking to stream that data through, I know a security group is actually looking at this. If we're looking to stream the data through, that no persist option is the way we do that. And would that allow us to essentially set up any kind of data format that went through core data, so you maybe didn't have to use the core data model? Have I got that question down well there, Riaz, or was there another part of that I missed?
That's good. That's basically the key part of it.
Yeah. So the answer to that question is, and I'm going to buzz back to a diagram here because it's going to help me a little bit. Yes, when you turn off the persistence, obviously then the data would go through core data and not hit the database. It's still going to work its way up through the rest of the system, and so the rest of the system would expect it to be in that same model format. In fact, the device service has to get it into that event reading format. That's the way EdgeX works. Could we alter that? Could we adjust it so that in the case of stream, we don't care what the format is? We could. We'd have to make some small changes here and there. And importantly, we'd have to know what that means on the top layers and things like the export service or rules engine, that even though the data may not be persisted, it would still need to know what the format of that information is if any kind of actuation has to go back down. So I'm not suggesting that we can't do that, but it does somewhat violate the purpose of EdgeX, which is this transformation mechanism that allows all the northbound activity to actually actuate and do its job. If we don't have a common format, we're back to where we are in IoT today, which is everybody has a standard, that's great, but now we don't know how to talk to each other and nobody knows how to do anything, and we'd have to re-educate each piece on the northbound side about your format, which is a bit problematic. So my take on that, subject obviously to the community and where we go in the future, is if we are talking about streaming just for the purposes of not having to persist the data, and we still want that transformation to occur so that everybody else can use that information inside the edge, we want to use EdgeX. If, however, we only want to stream this through so that we can get it through and into a system and maybe in a secure fashion, and also have something like a device service in place that helps facilitate that with Brownfield, my advocation would be that's fine. Let's use then device services to just bypass everything and communicate that data to some northbound pointing mechanism that doesn't have to have anything to do with local edge services. Does that help answer your question, Riaz?
Yeah, it does. I guess it depends on what the use case is and what the purpose was. We didn't hear much about that. The question that came up was simply the part I mentioned, which is I just want to get the data and send it up to the cloud, for example, or maybe to some sort of a fog server sitting on top of EdgeX.
Yep.
And
yep.
The concern was that are we adding a lot of overhead for that?
Yeah, I think those are good questions we're going to have to probably address in different forums, obviously. My advocation would be if it's just a mechanism to stream data north, there's probably better facilities to do that, and it's probably already in a silo that is particular to a use case. But good question and good observations. Other questions?
Yeah. Hey, Jim, Tony Espy, got a question for you. When I know that this is related to core, but when looking at the device services and especially the device service SDK, there's an object transform class. And I wonder if that's the class that's actually responsible for building the data format that core data wants to see.
Yeah, Tony, great question, and I believe so. I would need my super genius Tyler Cox online. I don't see him online to be absolutely sure because I haven't looked at that code today, but I'm pretty sure that there is something in the device service SDK scaffolding that provides for that transformation. I'm just not sure if it's that class or not, but that would be my hedge and my guess. I know it's there someplace. I just don't know if it's that one particular one you're talking about.
Okay, is there ever a situation where a device service wouldn't want to do a transform?
I think that kind of goes to some of Riaz's question. Yeah, that if we do not want to transform to a common model set, then the question is, well, if EdgeX's purpose is to help normalize so that everybody on the north side can send commands and can get data in a way that everybody understands the same, then if you're deciding not to make that transformation, what do we hang our hat on? What does EdgeX do for you? So it is possible, but then I would have questions as an architect. What is your use case and how does EdgeX help you?
Right, but it's nothing today that anything would want that data not to be transformed. Things won't work.
Yeah, I cannot think of an instance. And we've had some complexities about certain pieces of data we maybe needed to tag differently, and maybe is there better ways for us to do that? In other words, the model may have to be adjusted to address new and more complex use cases.
Okay.
But in the end, I think there will be some sort of normalization model that's in place so that one end can talk to the other end and not have to deal with that on their own.
Right, right. Okay, thanks.
Yeah. Other questions?
We do have one question that came through over chat, actually just now posted or reposted. Discuss JSON form briefly.
Sure, and by JSON, I'm assuming you meant JSON. We have lots of JSONs in our organization, and they would love to dearly have a format named after them. So I'm checking to make sure that that's not the case. But if you're talking about, yeah, there we go, JSON. Yep. When you talk about JSON, that is by default the format of the information as it's passed around with all of our services. If you're new to microservices, new to web services, new to communications between components in our computing world today, we have lots of different formats you can use out there. You could have just a string of values that are comma separated. You could put things in just flat text files. You could put things in XML. We chose JSON just because in a web services and a RESTful environment, that tends to be the most widely adhered to, let's call it standard, used by these communities to represent information, represent the things you're trying to communicate with. In this case, the sensing and device data and actuation back down. So that's what we chose. There's nothing, again, that says that EdgeX or any particular microservice couldn't offer different formats. And to be very precise, in the export service layer, we know that that's probably where more people are going to have more choices for different formats. So our export distribution service actually does facilitate and say, how do you want your data delivered to you? We can give it to you in JSON, we can give it to you in XML, we can give it to you in other formats. That's where there's more options there to choose your own format. But internal to EdgeX, and specifically here, talking about core data, we use JSON for that communication mechanism. Hopefully that answers your question out there. Others? It's Miller time on the East Coast and the Central Time Zone here. So we're probably getting ready for the end of day. I'll take one moment here, folks, while to see if any other questions might be coming in to kind of just wrap up and say thanks for everybody for joining. Hopefully these tech talks are helpful to you. If you do find them helpful, or if you don't find them helpful, let us know either way. Use Rocket Chat is a mechanism we're using a lot today. Also use the mailing list. Send me a personal email, anything to recommend or suggest alternatives or other ways we can get this information out to folks. And one plug I will make too, if you have the time next week, we would dearly love you to join us in some of the technical discussions. They're really going to be talking about what is this first release on EdgeX going to have in the fall, what we're calling the MVP. If you can be in London next Wednesday and Thursday, we'd love to have you. If you can't be in London in person but can join us on the phone calls, you will see that under the Technical Steering Committee, there's a page in the wiki called London Technical Meeting. It gives the time and the place and the information about what topics are going to be discussed when. So hop on when you think you have something to add or you'd like to find out more about the direction that EdgeX is heading, at least immediately. Okay, with that, if there are...
There's a couple, yeah, we got a new question that just came through over chat, or a couple, looks like, starting with Brian, a few messages up.
Yeah, Brian asks if we have any thoughts about how video or binary data may be captured and stored through EdgeX. Oh man, excellent question, Brian. We have thought about EdgeX in those environments that are more streaming from video, image, sound, another one. We do not believe that EdgeX in its current architecture probably supports those kinds of use cases really well. There are lots of other platforms out there that are dealing with streaming video and audio. For example, there are a lot of IoT systems out there advertising the pickup of a gunshot and being able to take action. EdgeX is much more about discrete data elements, temperatures and values, discrete values coming off of sensors and devices. That's not to say that in the future some of the same architecture, some of the same capability may not be useful or helpful. We just did not architect EdgeX to deal with that. So great question. Would love to get other people's reaction. If you have expertise in this field and in this area and you see maybe potential applicability, like to get with you and talk more about how you think that might occur. But that is really a entirely different use case that I think we'd have to study a lot more to make EdgeX applicable in those areas. Let's see. Open invitation to the London. Yes, it is open. Obviously, there is an expectation that if you're going to join us either by phone or in person, that you're willing to get in there and start working with us. This is really a working meeting. So it's not to say that we wouldn't appreciate anybody kind of just hanging out and watching what we're doing, but we're really trying to be focused, and we are focused not on necessarily the long haul for EdgeX. We are really focused on what the release coming out, what really is going to be the community's first release of EdgeX is going to look like in the fall. So if you're coming there to hear about strategy and other ways you can make money off of EdgeX, you may be a little bit disappointed, but absolutely an open meeting. That is what this community process is all about. Let's see. Audio and video conflicts a little bit with earlier statements about data format. That might be in terms of the idea of streaming. Certainly when you think about audio or video, if you can turn the audio or video into a packet of information, then that would certainly be something EdgeX could do. In fact, I'll give a perfect use case for that. We have one little device service we have in our labs that deals with a camera that has a chip on it. So it is taking video all the time, but that chip on that camera turns the image at discrete points into a count of the number of people it sees in our lab, for example. And so taking a video or audio and turning that into some discrete packet, or even a snapshot, a segment of video data, not a stream of video data, is something I think EdgeX could do. And that's where, again, maybe some of the persistence is either needed or not needed. So when you can turn the audio or video into a discrete piece of information, different story, and maybe that's where some of the conflict might be there. But if you're talking about just simply a stream of video, you're talking UDP types of things where you want to have intelligence that's watching the video feed real time and detects a face on there or something. That's a bit different and a different use case. So great question, great observation. Looking through the chat, don't see anything else. Brett, have I missed anything else?
Nope, looks like it's covered it.
Cool. All right, gang, one last call for questions. Otherwise, it's head to the bar time. Wish I could be there with each of you to enjoy that alcoholic beverage of choice, but I enjoy it in theory and in spirit at least. Going once, twice. Great. Thanks, everybody. Hope to see you all or hear from you all in London next week. Otherwise, we'll talk to you in a couple weeks.
Thanks, Jim.
Thank you.